Okay, so I wanted to make sure we understand these points completely, because latent heat of evaporation, very different than latent heat of vaporization, right? Evaporation happens at below boiling temperatures, at normal temperatures or even cold temperatures. We will see later on the relation that it depends on the humidity difference between a body that's taking up the moisture and a body that's giving up moisture. And it depends on winds. For example, if you imagine you have a hot cup of coffee, you blow on it to cool it down, right? So there is evaporative loss happening there. Or, as we mentioned before, your body sweats to evaporate the sweat and cool your skin down. So evaporation is conversion of liquid to gas below the boiling point, and for water it's 580 calories per gram. So it's more than 540 calories per gram that we had for vaporization. Why is this important? Because each time there is evaporation from the soil, from lakes, from ocean, and so on, the hydrogen bonds are broken, and that energy is taken up by the particle of the molecule of water that's being taken into the atmosphere. And when that water vapor condenses, that latent heat of evaporation is being given up into the atmosphere. This is the main energy that drives weather and climate, right? So sun's energy is coming in, it's heating various surfaces, and it's heating the ocean and creating evaporation. That evaporation is getting water vapor into the atmosphere, and that condensation of the water vapor is creating kinetic energy and moving air around. So this is something we have to remember. We'll keep coming back to that again and again. So lower temperatures of surface water not at boiling point means you have to break more of the hydrogen bonds to lift the water molecule out of the water, and you're taking the energy from those hydrogen bonds. This is why you cool the water that's left behind. And we'll see that in the ocean you only pick up the molecule of water, so you leave the salt behind. That has its own consequences. When you evaporate from the ocean surface, you are leaving the salt behind. We will see when we look at density that the salt is then going to increase the density of the water that's left behind. That's going to sink or do other things that will create motion as well. So it's not just the atmosphere and the condensation, but it's also in the ocean, the cooling, the salinization that's going to change the circulation. Latent heat of condensation is, as I mentioned, cooled water vapor turning to liquid and releasing the heat to the environment, which is obviously exactly equal to the latent heat of evaporation, and it is very identical to latent heat of vaporization. So when we convert boiling water to water vapor and we condense the steam back into water, we're going to release that energy, right? So we are always moving energy from one state to another and back when we reverse the state back into what it was before. Latent heat of freezing is similar. It's when the water freezes, you have to take out the energy to freeze it, right? In the ocean and on land it can happen naturally, again because the moving air can pick up the heat from the ocean and create sea ice, or condensed water can be cold enough that it will create snow and fall on the ground, and that snow can then freeze if the temperatures are cold enough. So latent heat of freezing is the heat released when water freezes, and it's identical to the latent heat of melting, because when you add energy to snow or ice to melt the snow or ice, you're going to release the energy that was taken up during, or the energy is going to be taken up for melting. This is all going to become very important, because when you think about global warming, not all the energy that is trapped because of greenhouse gases, I'm getting a little bit ahead because we have not defined these terms, more energy is being kept in the system because we are increasing greenhouse gases by burning fossil fuels. We'll define these things later on. That energy is not only going to go to heat the atmosphere, land, and the ocean, but it's also going to go to melt snow and ice. So the extent of snow and ice is going to decrease as well. So part of the global warming is those kinds of changes that happen in the system. Okay, so this is the concept that is going to become very important for climate and weather.